Hi everyone, in this video we will talk about breadth first search, its working and algorithm. If this is the graph given to you, this is undirected graph where 1 is connected to 2 and 2 is connected to 1, and we can travel from 1 to 2 and 2 to 1 with same path. So in breadth first search we create a adjacency list for all vertex. We create array visit, then queue. Adjacency list of any vertex is list of all vertex connected to it. In visit we push vertex which is currently being traversed, and in queue we push vertex that are connected to traversing vertex. So if 1 is connected to 2, 3 and 4, then the adjacency list of 1 will contain 2, 3 and 4. Similarly, for other vertices we can create an adjacency list like this, where 2 is connected to 1, 3 and 4, 3 is connected to 1, 2 and 5, 4 is connected to 1, 2 and 5, and 5 is connected to 3 and 4. If we have to traverse a graph from vertex 5, then initially visit and queue will be empty and we will traverse 5. We push the vertex 5 into visit and push 3 and 4 which is connected to 5 into queue. Then we will take the first element of the queue, that is 3, and we will traverse the graph again. So we traverse 3. Now 3 is connected to 1, 2 and 5, but 5 is already in the visit, so we will push only 1 and 2 into queue, and we will push 3 into visit. Then again we will take the first element of the queue and we traverse the graph. Now 4 is connected to 1, 2 and 5, but 5 is already in the visit array and 1 and 2 is already in the queue, so we will not push anything into queue, but we will push 4 into visit. Now again we will take the first element of the queue, that is 1, and we traverse the graph. Now 1 is connected to 2, 3 and 4, but all the vertices are either in the visit or in the queue, so we will not push anything into queue, but we will push 1 into visit. So now queue will have only one element left, so we will take that element and traverse the graph. Now 2 is connected to 1, 3 and 4. All the elements are either in the visit or in the queue, so we will not push anything into queue but we will push 2 into visit. Now Q is empty, and if you see, we have visited all the vertices of the graph. So we traverse a graph from vertex 5, and this is how we traverse the graph, and this is how we push the vertices into visit and in the queue. So you can pause the video and see. Now we will do the coding. For coding, we are going to use JavaScript. To save time, I have already created a graph. This is the same example that we have taken. So let's start. First, we have to create an adjacency list. Which will store the adjacency list of all vertex. Then we have visit. This is array. Then we have queue. Now we will have the function breadth, which will take two argument src, that is this source and destination. So this is how we create a function in JavaScript. Then we will say if src in adjacency is equal to false. That means this is the first time the src, that the vertex, is called. Then we will initiate that vertex with empty array. So adjacency src equal to empty array. Similarly for destination, in adjacency equal to false. Then adjacency of destination equal to empty array. So we have initialized the adjacency list of source and destination. Now we will link the src with destination and destination with src. So now src in adjacency is true, and if destination in adjacency equal to false, then we will add destination into SRC in this way. We will copy all the elements of adjacency SRC and we will append destination after that. And again for destination also we will do the same thing, that is, if destination in adjacency and SRC in adjacency equal to false. Actually this is adjacency of SRC. Okay, so correct that. And in this adjacency of destination, means if the destination is in the adjacency of source, then we will not append that because it will be the double copy of the destination, so we will not do that. So if it is false, then and then only we will append the destination. So similarly for destination we will do, that is adjacency of destination equal to, we copy all the element from adjacency of destination and we will append the SRC. So we have initialized the adjacency list in these two lines and we link the SRC and destination adjacency with destination and SRC. So if you want to see how the adjacency is look alike, we can console this adjacency, and if you see in the console, so this is how the adjacency will be saved. In 1 we save 2 3 4, in 2 we save 1 3 4, in 3 we save 1 2 5, in 4 we have save 1 2 5, and in 5 we have save 3 and 4. So it's working. Now the main part, that is traversing. So for traversing we take different function, that is constant traverse which will take only one vertex, and we will traverse that vertex. So now the first thing that we have to do in this function is check whether this vertex is in visit or not, if it is visited or not. So if it is visit, that into visit, so visit dot push, and we will push the vertex into visit, and then we will traverse that vertex, and suppose phi is the vertex given to you, so we have in the Q, that is 3 and 4, we have to push into Q. So for pushing the adjacency elements into Q, we will use for loop, in which let num of adjacency vertex if num is not in the visit, so we will again use the same thing, that is if it is not include in visit, and if it is not include in the queue also, then and then only I will push the num into Q. So Q dot push. Now I can push the num. In this we are pushing 3 and 4 into Q, and the adjacency vertex is adjacency of phi. So 3 and 4 will be pushed into Q. Now the last part is to traverse all those numbers from adjacency. So if Q dot length is not equal to 0, then I will traverse the first element of the Q. So Q dot shift, so it will take the first element from the Q. Now we are ready to run this. Just we are going to see the visit console.log visit, so that we can see how we are traversing. So again, if you run this, so it's coming empty, that because we have not given the vertex to traverse. So from 5 we can traverse this graph. So now I think it will be correct. So you can see now how we have traversed the graph from 5 to 3 to 4 to 1 and 2. So it's working. So this is the coding for breadth first search. Thank you.